Okay, so we're going to move on to variable acceleration. So you've dealt before where acceleration is a constant, so i.e. it takes a particular value, whether that is gravity or whether it's a particular value generally. But we're now dealing with situations where acceleration is variable. And on the first slide of the PowerPoint, you can see two examples, one where acceleration is increasing and one where it's decreasing, and sort of the impact it would have. When acceleration is variable, then displacement, velocity and acceleration can all be written as functions in terms of time. So like the first example that I've got here. So a toy train travels along a straight track, leaving the start of the track at time t equals 0. It then returns to the start of the track. The distance s metres from the start of the track at time t seconds is modelled by s is equal to 4t squared minus t cubed, where t is between 0 and 4, including 0 and 4. Explain the restriction that t is greater than or equal to 0, less than or equal to 4. So what we can't just assume is that these are the time that it returns to the start of the track. We have to actually solve as a function. So the most of the beginning of this chapter is actually interpreting things as functions. So I know that s is the distance from the start of the track. So I know this is the case. Therefore, because we're dealing with distance, I know that displacement in terms of t, so I'm using function notation. Most of the time when I do these, I will change the problems into function notation like this. So I know that my displacement in terms of t has to be greater than or equal to 0, because the train is only going away from the track in one direction and then back to the start. It's not going back in the other way. So displacement, because we've defined it as being this particular direction, let's say right of the track, it has to be greater than or equal to 0. So as a result, 4t squared minus t cubed has to be greater than or equal to 0. So whenever we have a quadratic, cubic, polynomial, whatever it is, we generally want to be able to solve it, and this is going to give us our restrictions for t. So because it's an explaining question, I am going to actually factorise it rather than just solve it on my calculator. So if I factorise it, then I can solve the t squared and the 4 minus t part. So t squared has to be greater than or equal to 0. So therefore t itself has to be greater than or equal to 0. For all values of t. But we also know from the question, motion begins at t equals 0. Now, we might solve an equation like this where t can technically take values where t is greater than or equal to 0, but the question might say that the toy train doesn't actually leave the track until, or doesn't start moving until t equals 1, for example. So it might actually not be at the start, for example. We might have to adapt from a particular starting point where something is. So we can't just assume this is the case without acknowledging that motion begins from 0 in the question. We also know that 4 minus t has to be greater than or equal to 0. So therefore t is less than or equal to 4. So therefore the full restriction is that t is greater than or equal to 0, but t is less than or equal to 4. So that's the full restriction. There are a few questions where they are expecting you to explain these restrictions. Okay, question number 2. I use a different pen colour just because I can. Okay. Example number 2. So a body moves in a straight line such that its displacement s meters from a point 0 at time t seconds is given by s. Now I'm just going to write it as s in terms of t because it means that when I do substitutions later, this is easier. So displacement is equal to 2t cubed minus 3t for all of t is greater than 0. So find s when t equals 2. So 2 lots of 2 cubed minus 3 lots of 2. Well, don't waste any time doing this by hand. You've got your calculator, substitute it in. So when t is 2 seconds, displacement from a point 0 is 10 meters. The time taken for the particle to return to 0. So the displacement from the point 0 is s. So I know that the displacement from the point 0 is nothing if I've returned to 0. So I therefore am going to need to solve my problem because therefore this must be equal to 0. This isn't a show that question or explain question, but I'd probably be reluctant to use my polynomial solver personally, just because this is quite straightforward to solve. Obviously you can, I'm going to do it in full by hand. So 2t squared minus 3, t lots of 2t squared minus 3 is equal to 0. T equals 0 is a solution, but obviously this is not the solution we want. This is obviously the starting point. Okay, so we want the other solution, which is 2t squared minus 3 equals 0. So 2t squared equals 3, t squared equals 3 over 2. So therefore t is equal to the square root of 3 over 2. Obviously I'm not using plus or minus because time cannot be negative. Time is a scalar product. So we cannot do it, have a negative time. So I'd pop that in the calculator. 1.22 seconds to 3 significant figures. Okay. Third example, and I think you can probably just about see without the other bits on the other side distracting you, trying to save my paper as I'm doing these. Okay, example 3. A body moves in a straight line such that its velocity, v meters per second, at time t seconds, is given by velocity in terms of time is 2t squared minus 16t plus 24 for all of t is greater than or equal to 0. Find the initial velocity. So initial velocity is obviously when t is equal to 0. So velocity when t is equal to 0. I shouldn't even really need to substitute this in because evidently this will become 0. Evidently this will become 0. So clearly the initial velocity must be 24 meters squared. B. Find the values of t when the body is instantaneously at rest. So they use the word instantaneously because it means at that specific, that literal moment it is at rest. When a body is at rest, what that means is that velocity itself is equal to 0. Oh, minus 16t, not plus. I'm not going to bother factorising this. I've got my calculator. I'm going to solve it. So t is equal to 6 seconds and is equal to 2 seconds. I've only written it in that order because that's the order my calculator gave it to me. You can obviously write it the other way round. So it's at rest at t is 2 seconds and t is 6 seconds. C, find the value of t when the velocity is 64 metres per second. So obviously our velocity function is equal to 64. It's a quadratic, so we want to make it equal to 0. So plus 24 subtract 64 is negative 40. So we'll solve this. So on my calculator, I do get t equals 10 seconds. Technically, one of the solutions is negative 2, but t can't be equal to negative 2. Now, it says find the value. It's not a complex question. They probably won't expect you to put that, but you can. I mean, it's good form to show that you've solved it properly. You do acknowledge that that solution isn't a valid solution in this case. Obviously, if you did put t is equal to negative 2, you would definitely lose marks. Okay, find the greatest speed of the body in the interval where t is greater than or equal to 0, less than or equal to 5. Now, when you talk about the greatest speed, that might make you think, okay, so I need to find a maximum, so therefore I need to differentiate. Now, if you look at the general function, 2t squared, that's a positive quadratic. So we know that positive quadratics generally have that shape. So it's going to have a minimum point rather than a maximum. So we can't differentiate this point, okay? What we can do is we can sketch our value, okay, or sketch our curve. So I know that it must have a y-intercept at positive 24. I also know that, so if I label my axes, the velocity, probably don't need that, velocity and time. So I know it has an initial velocity at 24, so when t is 0, v is 24. I also know that it has roots, so when velocity is equal to 0, at 2 and at 6. Now, obviously, I'm only looking at my speed in the section between 0 and 5. Now, because we're talking about greatest speed, I do need to know what the velocity is at t is equal to 5. Now, evidently it's going to be negative. Remember, velocity can be negative, okay? Because it's talking about direction. Obviously, it's gone in one direction, then it's travelling back to another direction, okay? So we do need to know what this value is, okay? So I want velocity when t is equal to 5. So 2 times 5 squared, subtract 16 times 2 plus 24. I can put brackets, but I don't need brackets because my calculator will do BIDMAS for me. Based on that graph, it should be negative. 2 times 5 squared. Subtract 16 times 5 plus 24. Oh, now I've got a negative answer. Oh, I must have... Oh, I think I possibly put 16 times 2. Did 2 times 5 squared and then 16 times 2. I can't quite remember what I did. I'm sure there's a way to rerun this and figure out what I did say. But it doesn't matter. Just shows you what you need to do. So I knew this needed to be negative. So I knew that I did something wrong here, which is fine, which is why I've left it in the video, because we all make mistakes, whether it's typing into our calculator incorrectly, whether it's reading the question wrong. But it's having that sense to know, I should have got a negative answer, I didn't, so I must have typed something in wrong. Now I know I must have typed something in right. You'll probably spot it in the video, and I'm sure when I watch my video back I'll know what I did. I have a feeling I put 16 times 2 there. You can also see that I put brackets just in case the calculator did something weird in terms of BIDMAS. It evidently wasn't. I must have put a 2 there because I do know my calculator does BIDMAS. And in fact, I'm actually going to delete the brackets to prove to you. Yes, it's -6. I must have put a 2 there or something. So velocity at t equals 5 is -6. So that means speed at 5 seconds, because speed doesn't have a direction. Speed is the magnitude of that velocity, is 6 meters per second. So that means the greatest speed at that point at the moment is 24. I have, however, got my minimum point. So on my calculator, I can find my minimum point. So I go to my equation function, my polynomial solver, and I act as if I just want to solve it. So 2x squared minus 16 plus 24. So it gives you my 2 roots. It then gives you the minimum coordinate. So it occurs at 4, and it is -8 is the y value. So I can't go back, but if you press equals, go through. Minimum of this function is x is 4 and y is -8. So therefore, the speed at t equals 4 is 8 meters per second. So overall, therefore, the maximum speed in the interval (0 to 5) is 24 meters per second. So it's just about interpreting your knowledge of functions. So this is going back to really early in Pure. So it's applying your knowledge of functions to a situation involving displacement, velocity and acceleration. And for now, that is it.